Hey guys, today we're going to be going over lesson 4.2. That's understanding theoretical probability. I can determine the theoretical probability of an event. So let's get to it. Let's start by going to the warm-up. This would be on page 4. So Betty and Carl conduct an experiment. Hold on, sorry, I'm trying to get my pointer. Betty and Carl conduct an experiment. They will flip a coin 100 times and record the results of each flip. What should they expect the results of their experiment to be? Justify your answer. So let's talk about first, well, what are the two options, or more than two options? Well, this one happens to have two. A coin flip can be either heads or tails. Those are your options. That's it. So how many outcomes do we have? We have two total outcomes, and it's either going to be one or the other, right? So you have a 1 in 2 chance of getting a heads, and you have a 1 in 2 chance of getting a tails. So if you wanted to turn that into a number, we would say 0.5, because 1 divided by 2 gives you 0.5. And if you wanted to do the percent, you would say 0.5 times 100, and then give you 50%. So you have a 50% chance of getting heads, and you have a 50% chance of getting tails. Well, that's all great and dandy, but that doesn't tell me how many I have for 100 flips. So if I wanted to figure out how many do I have for 100 flips, I would take this, and I would put it 1 over 2, and I'm going to make a ratio. And I want to make it equivalent fraction. So if my total outcomes are 100 flips, I want to know, well, how many would be for heads and how many would be for tails? And we put that over x. And then we do our cross multiply. Now, most of you may already know, well, what is half of 100? It's 50, but let's show what it would look like anyway. So we have 2 times x, or just 2x, equals 1 times 100. Well, we're multiplying. You remember when a number and a variable are next to each other, that means multiplying. We're multiplying by 2, so to undo that multiplication, we need to do division. And you can also think of this as saying, instead of just saying it's 2x, you can think over here, I'm going to put it over here, it's saying x times, or x plus x, right, equals 100. So that means we have 2x's, so I want to know what it would be for 1x. Well, that means I need to divide this into, this is divided into 2 sections, so this needs to be divided into 2 sections. And this is divided into 2 sections, so this needs to be divided into 2 sections. So over here, we're going to do the same work. It's just, instead of seeing each x, we're going to just have it as 2x. So we're going to divide it into 2 sections. This will become 1, so we're left with just 1x is equal to 50. And again, if you need to see over here, that's like saying I have 2 x's, that's what it says here, 2 x's, and I divide that 100 into 2 equal parts of 50. Let me erase all this, guys. You don't need it. It was just to explain why we do the division. So now let's go on. That means each one you should expect 50 heads and 50 tails. So let's try 4.2 example 1. I'm so sorry, it's getting a little wonky. All right, so it says Talia and Yoshi design a game for the school fair. Contestants spin a pointer and the winner win a prize if it lands on either of the 2 red sections. How can Talia and Yoshi determine how many people are likely to be winners of the 500 people? Winners if 500 people play their game. So what are the number of possible outcomes? So we just literally got to go over here and count them. So we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. We started on lilac, so this is where we stop. We have 16 possible outcomes. And let's talk about a little bit of vocabulary before we continue, because we need to know the vocabulary before we start. Theoretical probability is the likelihood that a specific event occurs. And I know this all just popped up, but that's okay. Pause the video and just copy it down. I'm just going to talk a little bit. So again, theoretical probability is the likelihood that a specific event occurs. And we kind of talked about this in the other video and the other day, where you have your number of favorable events over your number of possible events. And an event is just a single outcome or group of outcomes. So for instance, in this scenario, we want to know the probability of red. And this is what you put here, the event you want to happen. We want to have red because those are our winners. So we put red here. What is the probability of getting red? Well, you put the number of red sections over the number of total sections. So let's do that over here. The theoretical probability that a contestant will win this game is the number of red sections, which would be 2, over the number of total sections, which would be 16. Now, we always want to list our probability as the lowest simplified fraction. So we're going to say, well, 2 can be divided by 2 and 16 can be divided by 2. So that would be 2 divided by 2 is 1 and 16 divided by 2 is 8. So you have a 1/8 probability. Now, what does that mean? It just means at every 8 spins, 1 person should win. Just like every 16 spins, 2 people should win. So that is what the chances are. And if we wanted to see what that is as a decimal, we would take 1 and divide it by 8 and then multiply. That would get us 0.125, or if you want to see it as a percent, we would say times that by 100, 12.5% chance of winning. So now, well, they didn't really ask us what our theoretical probability was. They asked us how many people will win out of 500 contestants. And there's plenty of reasons why they would want to know this, especially if they're running a prize booth. Well, you want to know how many prizes to buy. You don't want to buy too many and waste money, but you don't want to buy too little and not have enough prizes. So if you know what the theoretical probability of people winning, you can have a general idea of how many you should buy, and you probably buy a little bit more because theoretical is not real life. It's just what should happen. What is the likelihood of happening? So let's set up our proportional reasoning. We're going to use proportional reasoning in order to find out how many winners there are going to be or likely to be. So we have I'm going to leave our fraction, our simplified fraction of 1/8. That's what our theoretical probability is. But we don't want to know that. We want to know what portion of people will win out of 500. Well, since the total is always on the bottom, we want the portion we want of that total on top. So you'll always put the X on top and whatever the total amount of people there are on the bottom. And now we'll do our cross multiplying again. We have 8 times X, or just 8X, equals 1 times 500, which is 500. And again, if you think about this, I'm saying I have 8 X's that have to share 500. If I want to know how many 1X gets, I'm going to divide it into 8 equal parts. So we divide by 8, that gives us 1 for our 1X. We divide by 8 over here, and that gives us an X of equaling 500 divided by 8 gives you 62.5. Now, we talked about this in class, and you'll see on this video, you can't have half a person, and you can't round up because otherwise that's not really what the probability is. So we always go with the lower number if we don't round up for probability. So of the 500 contestants, about 62 people are likely to be winners because we can't have half a person. All right, let's try example 2. Archie plays a word board game. He places 98 letter tiles and 2 blank tiles in a bag. Players will draw tiles from the bag one at a time without looking. What is the probability that the first tile drawn will be J, K, or L? So we need to figure out first, what is the number of outcomes we have? And that would be 100 because you have 2 blank tiles and 98 letter tiles. So the number of outcomes total is 100. And we need to figure out, well, how many are J, how many are K, and how many are L? Well, if we go look, we have, and I'm going to use my highlighter, we have J, K, L here, and then we have 3 L's here. That makes a total of 6. So then we want to know the number of favorable outcomes, and that would be 6. So now we know our favorable outcomes go on top and our total goes on bottom, and that's not a simplified because they can both be divided by 2. So now we have 3 over 50, or 3 out of 50. If we turn that into a decimal, we say 3 divided by 50, which gives us 0.06. And then we will times that by 100 in order to get 6%. So what does that mean? What is the probability of the first tile drawn will be a J, K, or L? There is a 6% probability or chance of picking J, K, or L. And that's how you find theoretical probability. That's just saying, in theory, you have a 6% chance of picking that one. Is that true? You might pick all three in order, and that would be really, like, out of beating the odds, as they call it. So I'm actually going to skip this one because this is not the one I meant to put in here, and we will do this. We just won't do that one, so skip it. And that's all you have for notes today. If you have any questions, please let me know, and go ahead and start your Math Excel. Bye, guys.